Hello everyone and welcome to my channel. In this video, I'm going to talk about reinforcement learning, which is a branch of artificial intelligence that allows machines to learn from their own actions and rewards. Reinforcement learning is one of the most exciting and promising fields of AI, as it can enable machines to solve complex problems that are beyond the reach of traditional methods. But what is reinforcement learning and how does it work? Let's find out. Reinforcement learning is inspired by how humans and animals learn from trial and error. Imagine you are playing a game of chess with a friend. You have a goal: to win the game. To achieve this goal, you need to make a series of moves on the board. Each move is an action that you choose from a set of possible actions. After each move, you get a feedback from the game, either a reward or a penalty. A reward is something positive that tells you that you are closer to your goal, such as capturing an enemy piece or checkmating your opponent. A penalty is something negative that tells you that you are further away from your goal, such as losing a piece or getting checkmated yourself. Based on this feedback, you learn which actions are good and which actions are bad for achieving your goal. You also learn to adapt your actions to different situations on the board. This way, you improve your skills and performance over time. This is essentially how reinforcement learning works. In reinforcement learning, we have an agent, which is the machine that learns from its own actions and rewards. The agent interacts with an environment, which is the world or the problem that the agent tries to solve. The environment can be anything from a game like chess or tic-tac-toe, to a robot that navigates a maze, to a self-driving car that drives on a road. The agent observes the state of the environment, which is the information that the agent has about the environment at any given time. For example, in chess, the state of the environment is the position of all the pieces on the board. Based on the state of the environment, the agent chooses an action from a set of possible actions. For example, in chess, the agent can choose to move any of its pieces to any legal square on the board. After choosing an action, the agent receives a reward from the environment, which is a numerical value that measures how good or bad the action was for achieving the agent's goal. For example, in chess, the agent can receive a positive reward for capturing an enemy piece or winning the game, or a negative reward for losing a piece or losing the game. The agent also transitions to a new state of the environment, which reflects the outcome of the action. For example, in chess, after moving a piece, the agent sees a new position of all the pieces on the board. The agent's objective is to learn a policy, which is a rule or a strategy that tells the agent what action to take in each state of the environment. The agent wants to learn an optimal policy, which is a policy that maximizes the total reward that the agent can get over time. To learn an optimal policy, the agent needs to balance between exploration and exploitation. Exploration means trying out new or random actions that might lead to higher rewards in the future. Exploitation means choosing actions that have already proven to be good and lead to high rewards in the present. Both exploration and exploitation are important for reinforcement learning, as they allow the agent to discover new possibilities and improve its knowledge and performance. There are many benefits and challenges of reinforcement learning. One benefit is that reinforcement learning does not require any prior knowledge or supervision from humans. The agent learns everything from its own experience and feedback from the environment. This makes reinforcement learning suitable for problems where human expertise or guidance is not available or reliable. Another benefit is that reinforcement learning can handle complex and dynamic environments that change over time or have uncertainty or randomness. The agent can adapt its actions and learn from its mistakes in response to changing situations. A third benefit is that reinforcement learning can achieve superhuman performance and solve problems that are beyond human capabilities. For example, reinforcement learning has been used to create agents that can beat human champions in games like Go or StarCraft 2. However, reinforcement learning also faces some challenges. One challenge is that reinforcement learning can be computationally expensive and time-consuming. The agent needs to interact with the environment many times and collect a lot of data before it can learn an optimal policy. This can be impractical or costly for some problems or environments. Another challenge is that reinforcement learning can be unstable or unreliable. The agent's behavior can vary depending on how it explores or exploits its actions, how it receives or estimates its rewards, and how it updates or improves its policy. This can lead to suboptimal or even harmful outcomes for some problems or environments. A third challenge is that reinforcement learning can raise ethical or social issues. The agent's actions and rewards may not align with human values or preferences, or may have unintended consequences for humans or other agents. We have reached the end of this video. In this video, we have learned what reinforcement learning is and how it works. We have also seen some of the real-life applications of reinforcement learning in various domains. And we have discussed some of the possible consequences of reinforcement learning, both positive and negative. I hope you enjoyed this video and learned something new. If you did, please like, share, and subscribe to my channel. And if you have any questions or comments, please leave them below. I would love to hear from you. Thank you for watching and see you in the next video.